Hello, everyone. Can you hear me? I can hear myself, so that's a good thing.
Yeah. Is mine working? Okay.
So my name is Gerhard.
And I'm Wayne.
This is Wayne. At Pivotal, we do things in pairs, so that's how things work. So this is like your pair. I'll start the talk, and then Wayne will help me within 10-15 minutes. I need him to help me, so I can go first, I suppose. This talk is about real-world RabbitMQ deployments, and having spent many years helping and learning from enterprise customers, mostly Pivotal, but also VMware and other companies, and having learned from users on the mailing list, and having collaborated with them, there are many things that seem to have in common and seem to have been helpful. So I'm here today with Wayne to share some of those things that I hope that you can apply straight away. If you are inclined to use your camera to take any, or phones to take any screenshots, don't. This talk is available online. I'm not going to share the URL so that you don't skip ahead, but there's a URL where you can view this talk. So let's just focus on the content. The one thing which became obvious after year 1, year 2, is that the RabbitMQ broker works in every case. RabbitMQ broker is very flexible. It's very mature, and the flexibility sometimes it works not in its advantage. Let's put it like that. Michael was commenting all the things that you can do with queues and some things you should never attempt to do, and yet you still can. So that tends to be a source of many, many issues. The one thing which I really like about the RabbitMQ broker is that it gets better with every release, which every patch release, which roughly ships every month. So there are constant improvements being delivered in the broker every month. That's great. There are some very big improvements, such as the quorum queues, which you have no idea how big it is. Even I don't know how big it is because I haven't worked as closely with it. But it's a big improvement, and they tend to ship roughly every year. The limitations of RabbitMQ and, more importantly, the applications are better understood, and we're pushing them further. We'll cover some of them. But there is one thing that is not problematic, but things get interesting. When it comes to applications, their runtimes, and the IaaSes where those applications run. The broker doesn't work in isolation, right? It has all these clients, all these services that it needs to talk to, and that's typically when problems start. Some applications are engineered better than others. Some are very good, some are very bad, some are terrible, like you should never put them in production. It's what it is. But the biggest problem is that some applications are built and they can never be improved. So there's no amount of configuration or tuning that you can do in RabbitMQ to make up for poor applications. And if you can't change your application, there's nothing RabbitMQ can do for you. And those are really tough discussions. The application runtimes are very diverse. Right? We live in an age where you can write code in anything you want. It doesn't really matter. You just push it to the cloud and it works. A Java runtime is very different to a Golang runtime, to an Erlang runtime. And because everything is more and more magical and easy, there are some trade-offs to be had there. If you're sharing a host with many containers, and those containers run within VMs, and the VMs run on a server, you have all these layers of complexity. Who knows where the problem is? Another thing which we keep coming across, not as often these days, but definitely 2-3 years ago, is you have this CapEx versus OpEx. CapEx is where an IT infrastructure, an IT department bought some hardware. We won't mention any names. They spend millions on it, so it better run good, right? And we better get the most out of it. And it tends to get overloaded. It tends to get maybe not ideal, but you had the investment, so you have to make use of it. OpEx, it's much, much better where you can, if it's not the right thing, you just put your credit card in, get a bigger instance. And we keep mentioning this over and over again. This precedes my time. RabbitMQ is not a database, right? RabbitMQ is a river. It's not a lake. Messages should flow through it constantly. And yet some people or some applications don't seem to do that. And then you need to expire messages. You need to do all sorts of things, which just complicates things greatly. So you're asking the broker to do all this work for you, to do all the metrics, all the things, and then the message just goes away. So all this work for nothing. And the one thing which I would say is, if you can, keep your queues empty. I know it's not practical in all scenarios, but that's when RabbitMQ shines, when things just flow through it. It is a message broker. Again, it's not a database. So let's come to some specific workloads, some specific requirements from RabbitMQ. This is a low latency. We call it a low latency RabbitMQ. Some considerations and some challenges when it comes to low latency messaging with RabbitMQ. We came across this use of RabbitMQ in the context of financial trading. The specific use case had to deal with 4 financial markets and 7,900 financial instruments. All it means in terms like the 4 financial markets were 4 exchanges, the financial instruments are routing keys, and you had all these messages which had to flow through RabbitMQ very, very fast. You had 30,000 messages per second. The messages were fairly small. They were basically keeping track of changes in the financial instruments, like all the price changes basically. And the goal was to consume every message within 1 millisecond. So if a message took more than 1 millisecond, it was no longer useful. Like, they had to drop the message. The system would lose money if messages would take more than 1 millisecond. So where do you start? You deploy RabbitMQ, you run your application, and it's slow. What do you do? Well, the first thing that you should do when low latency is important is look at your network. We have 3 providers, Cloud A. And the Cloud A, when it comes to the raw network latency, the average latency is 0.49 milliseconds. This is before RabbitMQ steps in. It's like layer 3, layer 4. The maximum latency is 1.62 milliseconds, which is really bad. There were some spikes, right? And this is a public cloud. I won't mention any names. In a public cloud, different zones, containers, all sorts of stuff, you had spikes which were so big that there's no way RabbitMQ could have processed that message within 1 millisecond. There's no way, because your latency was 1.62. Cloud B is slightly better, but Cloud C is what you actually want. The publisher to broker, the network latency from publisher to broker, the maximum was 0.15 milliseconds, which is perfect. But I would like to emphasize the standard deviation, 0.02 milliseconds. So this was predictably low latency, which is key. Low latency is not sufficient. It has to be predictable. It has to be constant. Now, it's not enough to measure the latency from the publisher to the broker. You also have to measure the latency from the broker to the consumer. In this case, Cloud C again wins 0.09 milliseconds. I mean, that's amazing, right, to have such low latency. The maximum latency for Cloud C is lower than the standard deviation for Cloud B and A. And that is significant. Put together, Cloud A, 0.87 milliseconds. So that's the majority of the 1 millisecond. It's only spent in the network stack. There's no way your messages will flow within 1 millisecond, because RabbitMQ needs some time. Your publishers need some time. Your consumers need some time. Cloud C, 0.24 milliseconds, much better. We can do some work with that. You would think that point-in-time latency measurements are enough. They are not. You need to continuously monitor your network latency. And this is not just for like low latency messaging. This is for when your cluster has partitions. How do you know that it's due to RabbitMQ or to your network if you don't monitor your latency? In this specific case, we can see that the latency is nice and consistent, 0.08 milliseconds. And we can see some dips, which it's okay. This is fine. The problem is when you have spikes and they're very high. You need to be aware when that happens. Because your messages might start expiring, like your messages are not making through. Why? Because of high latency, network latency. This is the first thing that you can do today in RabbitMQ, and you will have a good time. You'll have low latency messaging with it. Publisher confirms. Publisher confirms keep the data buffers empty. There are many buffers between your application and the queue, never mind the consumer. Many processes, many ports, many things going on. If you do not use publisher confirms and send messages to one queue as fast as possible, you will peak, in this specific case, 68,000 messages per second. But look at the latency. The 99th percentile is 3,000 milliseconds. That's crazy high. That's like, if you publish confirm every message, you can only push 8,100, but the latency is 0.19 milliseconds. In our case, we had to push through 30,000 messages per second. The optimal publisher confirm configuration for us was every 13 messages. I wanted to make it 12 to match today's date. It's every 13, right? It's a lucky number. But there's a problem. Look at the line. The message latency, the 99th percentile, is just under 1 millisecond. There is very little headroom. Anything goes wrong, and you start dropping messages. Not good. The message latency top corner, 979, very, very high. Distribution, so on and so forth. There are many things which you should keep track. By the way, if you want to know how to do this or where this is available, this is publicly available. Talk to me after. Moving on. We know that if we publish confirm every message, we have a very low latency, but the throughput suffers. So I'm wondering what would happen if we make use of Erlang's concurrency and we ran more publishers and more consumers. Would the latency stay low? And it does. If we have 5 publishers and 5 consumers, we already achieve our 30,000 messages per second, but look at the latency, 0.27 milliseconds compared to 0.98, what we had before. A big improvement. And sure enough, if you have 20 publishers and 20 consumers going into a single queue, look at that latency, 0.59, and you're still achieving 65,000 messages per second. Great. Obviously, this can be counterproductive. It's very important to measure 50. If you do 50, your throughput goes down and your latency goes up. Always measure. And these numbers might not be optimal for you, but they're optimal here. This is what it looks like when you have 20 publishers, 20 consumers, you confirm every message. This is what the flow looks like. You have under 600 microseconds, the 99th percentile, you have high throughput, everything is great. This is just one queue, by the way. No sharded queues, no multiple queues, just one queue. Most of you use queue mirroring. Maybe. Most of the customers that I work with or users that I with, they use queue mirroring by default. This is the latency that you get when you have one queue mirror, 20 milliseconds, right? 30,000 messages. You add another queue mirror, it doubles. And it gets much, much worse from here. This is when I introduce my friend Wayne. He's going to be talking about some tooling that was used to, I think, yeah, there it is. So if we do this, just give me a second. If we do this, we stay here. There we go. Okay. So Wayne is going to talk about some of the tooling that we use to measure message latency and other things. He's going to bless your Rabbit for a specific workload.
So in my role with Pivotal, I work with customers in either a pre-sales or after they've purchased in a consumption, helping everybody's subscription today. And so we're helping them to consume the product. And in the case of this large enterprise customer, they were trying to implement it was an MQ broker replacement, and they had various types of workloads. Those workloads included the fact that they were using other of our services that also use RabbitMQ. In their case, that was Spring Cloud Services, which is a set of services that we have in developing cloud-native services. So they went through all the generations of we call them tiles, which is our packaged release of RabbitMQ that runs on Cloud Foundry. I really don't get involved in RabbitMQ unless it's running on Cloud Foundry. So in their case, they were using it with Spring Cloud Dataflow, Spring Cloud Streams, and Spring Cloud Services, all using the RabbitMQ underneath, as well as all the applications that they were migrating from MQ Broker. So they have been with us now for about 3 years. And in our early days of working with them, because there was so much effort and energy being applied to replace the old workloads onto RabbitMQ Broker, we actually had weekly meetings with them, of which some of those Gerhard was involved in listening to them explain their performance or reliability issues that were coming up with RabbitMQ. In our early release of RabbitMQ on PCF Tile, it was a pre-provisioned, we use a provisioning tool underneath Cloud Foundry that's called Bosch. And Bosch is really a VM, for simple terms, a VM manager that would manage the clusters that we spun up. So those pre-provisioned Rabbit clusters would basically provision a new client by distributing or provisioning a vhost for them. And so it was a multi-tenant environment, and in their particular scenarios where they're trying to run Spring Cloud Services and Spring Cloud Dataflow, and then also their applications on RabbitMQ, they were finding that multi-tenant model to be very hard to manage. And so it used to look like I'm showing on the right, where the applications used containers. They're always all deployed in containers. And then the Bosch releases of Rabbit were managed VMs. And it would go through an HA proxy and then hit the clients. So where I bring up, that was just background to introduce that what we wanted to help them with recently was the fact that our new generation of Tile is referred to as an on-demand broker. So the on-demand broker brings up a separate cluster per request for provisioning that isolates that workload. They had done this previously with almost a hack or workaround that we had that we called Tile Replicator. So the Tile Replicator would bring up another multi-tenant environment. They actually had 3 that they were running, and they separated out Spring Cloud Services that were using RabbitMQ from their transactional workloads, from their more transient type of workloads. So they had 3 that they were running. And so they wanted to test how the RabbitMQ would perform under 2 new scenarios in their new data center. One was the fact that they were migrating to on-demand RabbitMQ Broker, which would provide the isolation they'd been waiting for. And the second one is they wanted to introduce a product that's shared by our sibling company, VMware, that's called NSXT, which provides a rich policy-based security and network isolation for a container-to-container networking. So with a meeting with Gerhard, he introduced them to this project that it's accessible to all of you that's called the Workloads Project, and somebody else was referring to it earlier this morning. And so we went into the data center to help with that. This is a slide kind of talking about some of the issues that we'd already worked with, which were limitations in some of the previous, with the previous release. And so we were here, when we went to the new data center, there was one other issue that was very interesting to them, and that was the topic of how could they distribute the RabbitMQ cluster across AZs. They had read a paper that was authored by Dan Carwin that's sitting down here on the impact of AZs and RabbitMQ clusters, and what they wanted to do is avoid the network partitioning, or split brain as some people call it. And so the advice that was given when it was the article that Dan wrote, the white paper, was basically addressing AWS, Google, and Azure, but didn't really say a lot about vSphere. We suggested they use the Workloads Project and test it for themselves, because given the right situations, vSphere could distribute RabbitMQ nodes across AZs. And so that was part of what we were testing. So running the workloads project, I've mentioned this already, we ran 3 of the workloads in the project. And how many of you have used the workloads project? Okay, there's just a few hands that have gone up. So I actually encourage every client, the situation they'd come to us is that they said, we want you to tell us what type of topology you need to run with your RabbitMQ. So just give us the right answer. And we said, we'd rather you run the workloads project and you tell yourself whether you have the right topology and whether this is working. And in a particular case, I think it was the LQ one, the LQS, was actually done with discussion with Gerhard, listening to the client's description of their workload, and then these use cases are laid out for them. So it gives it away by, this was, the LQS was the lazy queue implementation, and the DQ was durable queues, and within that pages, we took you out there, you'd find that it describes what physical configurations are being used under what network. It actually shows you typical off of our continuously running performance tests what Datadog is revealing through monitoring those executions. And then it's based on the perf test tool that if you've been using Rabbit, you're probably familiar with. And in our case, there was also an implementation that allowed us to do what we call CF push for Pivotal Cloud Foundry. So you can push the application out using perf test parameters. You can affect everything that you saw in earlier demos today. Number of consumers, number of publishers, delays on messages, and 50 other parameters that you can pass. So we actually ran that with this. In this case, on the final testing that we did with this client, what they really wanted to do was test the saturating the network. So we used the non-durable queues with AutoAct that would basically keep everything in memory, write nothing to disk, and flood the network. And in their case, I don't know if you can see this, but there's 210. They show this was all AZs. So they spread a RabbitMQ cluster on vSphere across AZs. And in the bottom one, it showed where it was a single AQ, or I may have that mixed up. But what we found out by running the workloads project, in their configuration using the admin tool, that there is very little difference in the executing on spreading the nodes across AZs and having it all in a single AZ. There is a slight degradation, but not enough to bother them. And in their particular situation, they wanted to be able to stripe their RabbitMQ nodes across AZs. That will not fit others, and in fact, that's oftentimes the most frequent, one of the more frequent questions that comes in to support us. Why am I having a split brain or a network partitioning? Because they've spread their nodes across their AZs, which is not typically a good idea. But in this particular vSphere configuration, it worked. So this is just one example of how we used actual testing for the client to be comfortable with the RabbitMQ configuration that they wanted to use in their production environment.
Thank you, Wayne. Coming back. There we go. So Wayne gave you a taste for high throughput, and he talked about how many messages per second to saturate the network. I want to also talk about a high throughput RabbitMQ deployment. This is in the context of vehicle telemetry and events coming from cars. And this specific RabbitMQ deployment had to handle peaks of cars. So you have 2 rush hours, morning and evening rush hour. When those peaks would happen, you'd have 1 million vehicles all pushing all sorts of events. Even though the messages per second weren't as high per se, you had only like 10,000 per second, the problem was their size. They were very big messages. And the other problem was that there were 2 services consuming those messages. You were effectively multiplexing the ingress. And those external services, they would have a maximum throughput, which would be lower than the ingress rate. And this is a problem because what do you do with the extra messages coming in? In this case, the right thing for this customer was to buffer those messages. I mean, if you have 300 million messages, I mean, that's a lot of messages. But the expectation was that all of them will eventually be consumed. The peaks, the rush hour peaks, were going to go away, and the backend services would also be continuously improved. I obviously can't mention any names, but the customer is present in this room. And so I'm basically saying the same things again, because even though this message was delivered some time ago, it didn't make it through the entire org. So hopefully if I'm talking about this on stage, it's official, right? And everyone listening to this talk will do the things that we recommend them do, right? We talked about applications. The first question that you need to answer is, does RabbitMQ have enough network capacity? In this case, there was a lot of data coming in and a lot of data going out. And you have to count both data coming in and data going out, because RabbitMQ is a river, right? Those messages have to eventually go out. So it's not sufficient to provision sufficient capacity for incoming messages. You also have to count outgoing messages. Also, 5 plus 5, you would think it's 8, but it's 20. The reason why it's 20 is because you need extra capacity. So what happens if a load balancer goes away? I mean, are you going to drop half the messages or not receive? What's going to happen? So you always need to have more capacity. And these were just message bodies. There is AMQP overhead, there is TCP IP overhead. There are lots and lots of things which add overheads. You can't just count the message payloads and nothing else. The load balancers, so if you have load balancers in front of RabbitMQ, it doesn't matter how fast the RabbitMQ node network is, you need to do the same for the load balancers. I would argue that you might not want load balancers in front of RabbitMQ, but that's just my perspective, and it's very contentious. So let's discuss after this talk. I enjoy that discussion very much. So you can see here that we were measuring the ingress and the egress for the HA proxies. There were 2 HA proxies, and that's roughly 7 gigabits per HA proxy times 2, 14 gigabits. And they were the ones which had the highest network throughput. So you have all these messages coming in, you have sufficient network. Can your disks cope with those messages, or can your memory cope with those messages? There's a lot of data coming in. What do you do with them? So our recommendation was to send messages straight to disk. You'd use lazy queues. What you do not want to do is mirror those lazy queues, because that adds a lot of network overhead, and especially do not automatically synchronize lazy queues which have lots of messages in them. It's very bad. Let's talk about that as well. It's not sufficient to just manage disk throughput. There are 2 values that you need to keep in mind. The disk throughput, which is maybe bytes, megabytes, whatever it may be, and the IOPS. So the throughput might be sufficient, but your IOPS might not. You need to be aware of both values. And we have our friends from Intel are here today. They have a very good story about Intel Optane NVMEs. They're amazing disks. I can tell you more about them. We've done some benchmarks. They're great. So I can see here, we can see here the disk throughput. So we know what our limits are. Very important. We know where we are within those limits, both for bandwidth and IOPS. But if you don't measure these things, like finger in the wind, doesn't work. Really doesn't work. And you can also see the RabbitMQ messages which are queuing up. We have 150 million and slowly growing. Like, what's your capacity? Are you within capacity? What's happening? And also you can see that the memory usage is nice and flat and stable through all nodes for the entire duration of this peak rush hour. It's a simulation. Most of you might not know this, but there is an Erlang process which is responsible for persisting messages to disk. There is only one. In 3.6, there used to be 1 per node, right? So all the queues, everything on one RabbitMQ node would go through this one Erlang process that would flush messages to disk, would write messages to disk. And that would get overloaded in our case. Since 3.7, there is 1 per vhost, and the work that we did had somewhat an impact on our considerations for the persistent store. How do you know when the message store is under pressure? You might not have seen this or might not have noticed this, but your queues will enter in a flow state. That means that the message store is exercising back pressure on the queues. There's a very good blog post, goes way back when, which explains the back pressure in RabbitMQ, and the message store is the last link in the chain which exercises back pressure. By default, there are too many metrics collected, but users expect that and users like that, and that's like one of RabbitMQ's great features. Like you have the UI and you can see all the metrics, and that's great. But if you have many connections, many channels, many queues, it might not be such a good thing. Actually, in 3.6.7, the entire metric system was rewritten because one node used to handle all the metrics and would continuously crash over for this specific customer. And we have 2 team members which did an amazing work on that. It took them, quite a lot of toil to get it done, but it's so much better since 3.6.7. Do you need to generate metrics every 5 seconds? The fact that the UI needs to refresh every 5 seconds and is expecting fresh metrics, you might not need to capture them every 5 seconds. It might be bad for your use case. And do you need to keep them for up to 24 hours? Okay, you have buckets and you have rotations, but do you need them? My preference is to extract all the metrics into purpose-built systems, which are external to RabbitMQ. It will save you a lot of trouble, and it definitely works in this case. RabbitMQ sharding has been mentioned today, I think, at least once. RabbitMQ sharding works very well, but it's not the first thing that you should go to. So depending on your use case, in this case, it did make sense. We wanted to have a single logical key. You can't define it. It's just there in the system. You use it. And the queue is backed by queue shards that run on every single node. The queue is always available as long as there is one node available if you don't have pause minority. Let's talk about that as well, if you want. And the best thing in this case was that the publishers and consumers, they publish and consume from queue shards local to their node. So this will limit inter-cluster traffic. It's really good. And you can see here how we have all these different nodes that have a very even spread when it comes to ingesting messages and delivering messages. It's a nice even spread. RabbitMQ sharding makes it super easy. With that, we got to the last workload type. How much time do we have? Just so that I know how fast I have to go. Perfect. That's more than enough. So the last RabbitMQ workload talks about high scale. It was in the context of medical equipment. The problem here were the number of connections and, more importantly, number of queues. There were 100,000 queues. Every medical device had one queue. There were many long-lived connections, and the throughput was rather low, only 300 messages per second, and there were small messages as well. The challenge were the queues and the connections, but more the queues. Most users, like, how do you scale Rabbit? You just add more nodes, right? Well, maybe not. Actually, fewer nodes is best. There are a few reasons for it. Every node in the cluster communicates with every other node, so the more nodes you add, the chatter between nodes increases a lot. But that's not the worst part. When a node goes away, right, you have a cluster node goes away, all the remaining nodes have to clean up the state of that node, and they all do it concurrently. There's a to-do. It goes way back many years, but we're working on it. The worst part possibly is that the RabbitMQ metadata needs to synchronize across all nodes. So the more nodes you add, like any operation has to be synchronized on all nodes before, yep, it's all good. It's all good. These are the RabbitMQ metadata, like bindings, queue definitions, exchanges, stuff like that. This is what your 3-node cluster looks like, right? RabbitMQ is a complete graph. Every node talks to every other node. Looks very nice. This is what happens when you go to 7 nodes, right? It looks bad. Crisscrossing, lots of stuff. Yeah. Connections are not free. They cost memory. And it gets worse because machines have more and more memory. So by default, the TCP sockets are using more and more memory. Today, in a typical system, they will use about 100 kilobytes, even if they're not using anything. So if you tune this, you can free up many gigabytes of memory just by tuning this one parameter. And you can do this straight from RabbitMQ, by the way. You don't need to go in the kernel. Again, the default metrics keep coming up because you might collect metrics that you don't even care about. There's a lot of pressure on the metric system, even though it's better. Do you need to store all those metrics? Do you need to generate them as often and, again, extract? Same advice as before. Lastly, you'd think that every exchange and every queue type maybe is fast when it comes to operations. There are differences. So if you, for example, if you have to bind 100,000 queues to exchanges, if the exchange is a topic exchange and if the queue is a durable queue, you will top up around 22 binds per second. This is better now. It gets better all the time. But to do 100,000 queues, it will take 75 minutes. A direct exchange is the fastest, and a non-durable queue is fastest. The reason for this being there are less operations in Amnesia, and that means that the same queue binds, you can finish them in 6 minutes. It's a big difference from 75. If you want screenshots from this environment, you can ask me. But this is where I wanted to get to, the summary. It's very, very important to know what you're trying to get from RabbitMQ, right? Because it's so flexible, you can get anything from it, and everything is possible. Within reason, obviously, but everything is possible. You can go as crazy as you want. What are you trying to achieve? Is it low latency that you care about? Is it throughput that you care about? What do you care about? It's important not to mix workloads. If you have a RabbitMQ that's supposed to deliver you low latency and high throughput, that's not going to work. Think about racetracks, right? Like in a racetrack, cars go as fast as possible. Think about motorways. It's about volume. They're different problems. And surprisingly, 90% of RabbitMQ issues are down to applications. You wouldn't believe, right? Like what a difference a good application or a good client that knows what it's trying to achieve and it's configured for its intended purpose, it makes a huge difference. Maybe some of you are wondering, this is great, I want to help. How can you help? Well, contribute your observations. Take a look at the baselines. Wayne mentioned workloads. What's possible? What's the baseline? So that we can know, like, is your environment worse? Are you doing something bad? Are we improving things? Are things getting worse or better in RabbitMQ? We hope. It's important to know what the starting point is. Tell us about your workload. I'm sure you have workloads that we haven't heard about. Maybe you haven't even thought about this. Maybe, I don't know, durability, the most important thing, hence quorum queues. Carl will tell you all about it. What metrics are important? We would like to know when it comes to tuning different things or running different workloads, which metrics do you wish you had in RabbitMQ? We can make some assumptions, but we would like your input. By the way, all these are links. And the best part, this is live. That's why I said don't take screenshots. If you go to realworld.rabbitmq.pivotal.io, you will see this presentation. You'll also see, fascinating. You'll also see many slides, which maybe have not been presented here. Not slides, screenshots. There's an images directory. Go there, you'll see the full-size screenshots, the histograms, a lot more stuff. I think we have a few more minutes for questions, either to myself or Wayne. Thank you.
Thank you very much. Fire away.
Hi. What's your minimum node count in RabbitMQ Broker cluster with high availability?
Minimum node count with high availability.
Start with 2 is enough, or 3 is start?
I would say 3. I would say 3 because pause minority.
Thank you.
and quorum queues. They require 3 nodes.
So it was mentioned to not use multi-AZ in a cluster. I do so fairly heavily across multiple queues with high velocity throughputs. I was wondering what kind of scenarios you see where people are running into partition issues. Is it a traffic issue? Is it a cloud provider issue? Because I haven't seen it.
I think we would find it's a cloud provider issue because clusters require low latency for the heartbeat between the nodes. And oftentimes it's not fast enough when you spread that across AZs in, say, AWS. That's where I've run into it a lot. AZs, I would refer you to I've actually made a public version of what Dan did for us internally. But we talk about the concept of AZs from a PCF perspective and AZs from the cloud perspective. And they're not always talking about the same concepts. So it's really important to understand what they do. And if they get physically distributed, the time, just the time to pass the heartbeats between the nodes is not sufficient. And so Rabbit will get confused and think it's in a split brain scenario when it was just a latency issue with the heartbeat. Yeah, I've run into it even when it wasn't Pivotal Cloud Foundry, when they were just running on straight AWS.
So still coming back on this multi-AZ setup, what kind of partition handling mode were you using? Have you successfully been using pause minority across AZs?
It was. The default policy for PCF is pause minority. They don't have to select that, but that's generally what we see customers do because that's the default from our configuration.
So there were some very nice charts in this presentation. How can RabbitMQ users adopt this kind of awesome monitoring and generate all those charts? Can you please tell us more about it?
That's such a leading question. Thank you, Michael. Thank you. So the client charts, when it comes to message latency, PerfTest since 2.2.0 has native support with Prometheus, as well as others. It's using Micrometer, so it's able to expose a lot of metrics internally about the client via Micrometer. When it comes to RabbitMQ, there's a plugin, third-party plugin, community plugin, Prometheus RabbitMQ Exporter. We haven't seen any charts here, but it's another good way of getting those metrics in Prometheus if you use that. The charts that you've seen at the very beginning, they are Grafana. There's a dashboard. I mentioned that it's public. You can see more details here. You can see the link to the actual dashboard. That's a low latency one. We have a few others. We have one which basically tracks the Erlang memory allocations and memory allocators. It's very detailed. It's part of Beam dashboards. And there are a few others which we haven't made public yet, but we're slowly getting there. Did I answer your question, Michael?
Okay, let's thank Wayne and Gerhard with an applause.